Hello, it's AC Blender Tutorials. In this video, we're going to be applying the action constraint to our model. So the first thing I need to do is some cleanup. So I've been thinking about how I was approaching this, and I decided that I didn't want to use the mechanism bones. I didn't need to, because I'm used to more complicated rigs. And more complicated rigs, you have, say, IK chains and FK chains, maybe an animated chain, all different kinds of things. So what you do is you'd use the mechanism bones as part of which chain you're switching to, especially if you want to do dismemberment. And we're not doing anything nearly as fancy here, so I decided that we didn't need to get that complicated, so I'm just going to remove it. So we'll just start constraining these. So do leg 1, yep, to this one. Yeah, sorry for all the repetition. I'm making videos in this rig as I go through. It takes a lot of time to fully prepare all the videos up front as I've done in the past, which is part of why I haven't had many videos. So doing it this way means it's a lot easier to actually make the videos and juggle it with everything else. Alright, so we have all the parenting set up there. And what I'm also going to do to make my life easier is for the rigging purposes, or for the animating purposes, for the keys, for the action, I'm going to add these to the bone groups and give them a bone shape. So this will make it a lot easier for seeing what I'm doing. I'm only using this rig, or these specific bones, for making this action, and then they'll never be seen again. But it will be a lot easier to do this. And I actually have some cleanup work to do with the gizmo too. And also the axes. So I'm not sure what the gizmo uses to determine. Let me go back to this first layer. I'm not sure what the gizmo, why it wasn't working before, where it would only show the non-constrained operations, but now it seems to be working. So I don't want to get these movement arrows on these. So I'm going to go back through and lock all of those. And these are using the XYZ Euler, which is good because we're only moving it in one direction. So there's no reason to do anything else. And well, I'll just go back through and lock all of these. And then we'll come back for to change the rotation mechanism for these other bones. So I thought about it more. Whoops, need to make sure I do these two. Okay, they're good. So I thought about it more and decided that these are going to be better off being XZY Euler, because due to the way this is made, you're mostly just moving along certain local axes. So there's no reason to use quaternion, because they make it a lot harder to isolate different rotation when you're animating. Which is going to be a huge help later. I'm doing XZY just because we'll pretty much never be using Y. So there's no reason to have Y in the middle. That way, if you do decide to rotate one of the limbs, you don't have to worry about gimbal lock. Check the rest of my rig to make sure. With this one, X, Z, Y is also going to be fine. For the middle, for the body, I'm going to keep quaternion here because it does better when you're rotating through awkward angles. But for things like the head and the abdomen, they're not going to be rotating through awkward angles. Let's see, I think for this too, I'll use X, Z, Y. The head will be X, Z, Y. The root using quaternions is fine. And all right, that's everything. So now we're ready to get back to work. So here's our rig. And what I've done is I've already gone through and I figured out what angles it moves through. So going through some research pictures that I took in game, I figured out what the angles of the leg were, or at least what I wanted them to be. And then I ran them through some trigonometry to see, just to roughly have them moving the same distance as they go. If you don't do that, it doesn't come out right. The default Minecraft animation doesn't do that, and it's really bad. So this is still really simple, but it will look significantly better when we're done. Just because we've put some thought into how far the legs move. Okay, so I'm going to open up the action editor in the dope sheet. I'm going to create a new action. I'm going to call it Walk Constraint. And this is just going to be a really basic animation. So I'll just select these and actually turn on mirroring. Rotate XX for the local x-axis, and I'll move it 35 degrees. So that brings it just right to looking at the ground. And then based upon the numbers of the angles, let's start with these front legs as far back as they'll ever be. So the furthest back that they would be is -25. That's their local z-axis rotation. And then let's see. That's not looking right. I pushed a button wrong somewhere. Kind of fumbling through my keys. Z. Let's see. Okay, yeah, it's not the local Z I want, it's the global Z. So this is going to go through to -25 degrees. And then we'll go through for these. The forwardmost position is going to also be -25 degrees. Rotate Z, -25. Well, 25 degrees in the global. For the local, it's -25. These will be the furthest back that they will be, which is going to be 25 degrees. And then these are going to be the most forward that they're ever going to be, which is going to be 30 degrees. You see the legs are just about all touching in this extreme pose. Select all the bones. I'll set the keying set to rotation because that's all we care about. I'll keyframe it. So now we have all the keyframes for all of our rotations at our first frame. Let's go ahead and make our animation 20. Let's see. We'll get some nice granularity. So let's go all the way out and make it 100 and so we'll make it 101 is our final frame. Add another keyframe there. So 1, let's do our middle pose, plus 50 is our middle, plus 50 again will be our end. So now at the 50 mark, we'll move everything into the other extreme. So these will be negative 49 degrees. So negative 49, negative 49. What did I enter on that one? Why did that mess up? Oh, because this one's positive. Oops. This one moves back to 5, negative 5. This one goes forward to, let's see, this one goes forward to 5 as well. This one goes to negative 5. This one goes to 57. And negative 57. So these are all the extremes. So we'll select these. And then we'll put in another keyframe. Now if we set our animation to end at 100, frame 100, so what we want to do is we're setting everything to go to frame 101. We want it to loop back into frame 1 instead of 101, otherwise you're repeating this last keyframe twice. Okay, so it's moving like it should. This whole animation, based upon how far the legs are moving, is going to be running in about 1.1 seconds. So what we want to do is adjust our frame rate so that it runs closer to the real time. So in order to run 100 frames in the correct amount of time, we'd have to have a frame rate of 89. I'm actually working remotely on my laptop, so I don't know if it can even handle this. We're going to find out. So let's see if it can handle 89 frames per second. Looks like I'm more or less close enough. So this is the animation that we have right now. So what happens is, as the legs move forward, they're in the air. Then they hit the ground again, and they start moving backwards. So let's track. So at this point, the two front legs are moving forward, which means they're in the air. So we'll go halfway. So for 50 frames, halfway will be 25. 1 plus 25 is 26. So we'll select these two legs and then these two legs. You can see they're both moving forward, or all 4 of them are moving forward. And then we'll set the X, not from 35, but we'll set it negative 10 degrees higher. And then also what we're going to do is we don't want to mess up the interpolation of our Z rotation, just to add an X rotation to go up. Because this X rotation, the Z rotation should be smoothly moving past at a constant velocity on the ground. So we don't want to accidentally mess that up. So what I'm going to do is select each one of these individually and set in a single keyframe for the X channel on these rotations. All right, so now they go back. Now we can see the opposite legs are moving forward. So we'll go halfway again, so that would be 76. And we're going to edit those legs. So now what we're going to do is rotate XX minus 10 degrees to bring them up. There they are. And I'll set the single keyframes on these. Okay, now let's see what that looks like when we play it back. All right, very nice. That's very smooth. We're getting what we want. It's a little bit too smooth though, so let's select all of the legs, select everything in our dope sheet editor. And then we'll go to Key, Interpolation Mode, Linear. That's not ideal, but for a simple animation like this, it'll be fine. And there's the animation. And so this is the action that we're going to go with. I have a more advanced one that I made that I'll be using in the final rig. But this animation will be just fine for this. So add a fake user to it, and we'll remove it. We can just select all of our bones, Alt R to clear the transformation. It's like our animation never happened. Well, not quite. So what we're going to do is add the constraints onto these bones. So go into our bone constraints, we're going to add an action constraint. The target is where you can drive the action with an object. However, I want to drive these with a dial, so you can just keep rotating it to infinity and it will just keep replaying the animation. When you do an object rotation, it doesn't quite work right. So once it hits 180, it just stops incrementing until it loops back around from 360 or 0 back up to 180 again. It's really weird. So instead, we'll be using evaluation time, and we'll just be scaling it up with a driver, and that is something that we'll be able to do without any problems. So our action is going to be the walk constraint. First frame is 100, or is 1. Last frame is not 101. 101 is the first frame again, where it loops back. We just want to go to frame 100. And then now you can see that for the first leg, we can loop through the animation. And now what we'll do is we'll select the other legs. Select our first ones with the active bone. Constraints, copy constraints to selected bones, and there it is. Now that we have this done, I think I'll still keep these. In the next tutorial, it'll be easier for adding the drivers if we can still see the colors on these. So I'm not going to remove them from these bone groups yet, but their days are numbered. So that's it. That's how we have our constraint. And what we'll do is we'll have a driver to turn the influence of this up and down, to turn it on and off. Then we'll have another constraint, or another driver again, for the evaluation time. All right, thank you. I'll take care of setting up the control panel in the next video. See you then.